All right, so yesterday we talked about unit conversion. Sometimes people will call this dimensional analysis too. That's just a fancy word for unit conversion. And we started out with some easy examples where we said you can convert between dozens and eggs, and we know there's 1 dozen for every 12 eggs. So every time I do these, I like to write down my conversion factor. I like to make sure my units cancel, and then I circle my desired unit. So we worked through a few of these. And again, we said the conversion factor can be presented right side up or upside down. It doesn't matter, right? Because it's just a ratio that's supposed to be equal. And then we did some harder examples going from kilograms to grams, pounds to grams, and then kilograms to milligrams. The hardest ones, in my opinion, are the ones where you have to use multiple conversion factors, and that's what you saw in your problem of the day. So let's continue on and do some more practice. And we're going to switch to more word problem types. Lauren Peters? She might have sent me an email saying she was absent. Yeah, sorry. All right, so let's do a word problem example. Sometimes it's a little harder when it's in word problem form. So what is the mass of 1.00 liters of gasoline and then I'll say gasoline has a density of 0.703 grams per milliliter. So anytime I do these, I like to write out my conversion factor. We might need a few conversion factors here. One is just straight given to you, right? That was the density. So we can say 0.703 grams is equal to 1 milliliter, right? That's density. So that's one conversion factor we have. What's another one that we might need? Yeah, milliliter to liter, right? We're given the original volume in liters, but our second unit conversion doesn't have liters, it's in milliliters. Okay, so I'll put liters over here. I'll put milliliters over here. All right, what number goes where? How many liters are in a milliliter, or how many milliliters are in a liter? Check with your neighbor and see if you agree. All right? So let's do it this way. How many milliliters are in 1 liter? 1,000, right? So we would say 1,000 milliliters are in 1 liter. And remember, that's in that list of units I want you to memorize. So make sure you go through and make flashcards and get that kind of drilled into your head. All right, so we've got our conversion factors. Again, I like to start out with what we know. We know that we have 1.00 liters. We don't want our final unit in liters, right? We want our final unit to be a mass unit. So we need to cancel out liters somehow. So I'll put liters on the bottom. And the only unit conversion we have with liters in it is this one, right? So I'd say, all right, liters and milliliters can be related. And we know that there are 1,000 milliliters in every 1 liter, right? Which is good, because at this point we're canceling out liters and we're good to go. All right, next up, we want to cancel out milliliters. And we want our final unit to be a mass unit, which we know is probably going to be grams. All right, and then we've got this gram to milliliter ratio. And we know that there's 0.703 grams in every 1 milliliter. So now we can go ahead and cancel out milliliters, milliliters, and be left with grams. Right? Looks good to me. Go ahead and plug this in your calculator. Does anybody want to help me out with this? $703 grams. And remember, my big pet peeve is when students just write 703. I don't know what that's representing. Always, always, always include units. And then you can box your answer to indicate that's your final answer whenever you're showing a lot of work. Make sense? All right, let's do a second one. And I like this one. And I'll give you some physics conversions too, but bear with me. So how many joules of energy are in a 1,235 calorie hamburger? And I'm going to do a note. This is completely separate. Note, energy is measured in joules or calories. And energy is something that can do work, right? This is different from temperature. Temperature is measured in what units? Celsius, right? So sometimes people confuse temperature and energy. Energy is the ability to do work, right? Temperature is just a measure of how hot something is. So those are different. All right, so now what we need to do is come up with some conversion factors, and I'll help you guys out with this. Anytime there's a conversion on an exam that's not on that list of things to memorize, I'll give them to you, so don't panic. The first one is 1 calorie with the capital C is equal to 1,000 small c calories. It's a little bit confusing, but the capitalization is very important, right? So if we look at this one, capital C versus little c. All right, the second one is there are 4.184 joules, which is represented with a capital J, and every 1 calorie with a little c, so lowercase c here. So we've got 2 unit conversions that we can use. And I'll give you guys a minute to set this up, but check with your neighbor, see if you agree. Give me a thumbs up if you think you got it, at least set up correctly. All right, let's do this as a class. Again, I like to start out with what we know. We know we've got 1,235 calories with a big C. So 1, 2, 3, 5 calories with a big C. We want to convert this to joules, so we got to get rid of that calorie unit with the big C. So I'll put that on the bottom. The only unit conversion we have with the big C calorie is the one on top, right? So we can convert calorie to a little c calorie, and we know that there are 1,000 calories and 1 big C calorie, right? Looks good. So now we're canceling out big C calories. Whoops. We're left with the little c calories as our unit. Still not there yet. We need to convert that to joules. So we want to cancel out the little c calorie. We want joules. And then what number should go where?
1 on the bottom.
Yeah, 1 should go on the bottom because we know 1 up here is paired with the calorie unit, which means the 4.184 must go on the top. And again, I like canceling out my units, just double check. And what answer are you getting? Plug it into your calculator. Yep.
5,167,240.
So 5,167,240 joules, right? Is that what you got? Perfect. Okay, how many sig figs should there be? 4, okay? So what we can do is we can say we're not quite there yet. We don't have the proper number of sig figs. So what we could do is write this as 5,167,000 joules. That has 4 sig figs. What's another way of writing it? We could say 5.16 times 10 to the what? 10 to the 6 joules. Either one is an acceptable answer, and there may be situations where I ask for it in scientific notation, so know how to do that. You guys remember how to do the decimal point move? Just count the number of places you move your decimal point. All right, got a challenge one for you now, even harder. And then we'll do a breakout practice set. All right, challenge. Yep.
What's the difference between the big C calorie and little C calorie?
It's really just an arbitrary thing where it says anytime you see calorie with a capital C, it's referring to 1,000 little c calories. It's just, for whatever reason, that's what nutritionists did to confuse us all. Yeah. Scientists use the little c calorie. Nutritionists use the big C calorie. If you go to Europe or Canada, instead of doing the big C versus little c, they actually do a lowercase k, meaning kilocalorie, which is just way easier. But again, we're Americans, we're stubborn, we don't like to follow any rules that the rest of the world does. All right, moving on. I'm a big fan of track and field. How many of you have watched Usain Bolt run? Very fast guy, right? He's got the world record, and it's Usain Bolt. Ran 100 meters in 9.58 seconds. What was his average speed in miles per hour? A little bit tricky, but I'll give you a hint. My hint is calculate miles first, then calculate hours, after that divide. All right, so I'll give you guys a little bit of time to work on this. The other hint I'll give you is the unit conversion. And in this case, we know that 1 mile is equal to 1.61 kilometers. That's the only unit conversion I'm going to give you for this one. But I think you guys can do it. All right, just to help you out, I'll give you some more unit conversions in case you're stuck. The next one we'll do is say 1 kilometer is equal to 1,000 meters. All right, that's one you should memorize. All right, the next one I would do is say there's 60 seconds in 1 minute. Right, that's a common one you use day to day. That's one you can use. And you can say there's 60 minutes in 1 hour. So there's 4 different conversion factors you may need for this one. Hopefully that'll get you going. Another word of caution too, I've seen this happen before where students in class practice all of their problems on their iPhone or on their Android phone, and then they get into an exam setting and they don't know how to use their actual calculator. So if you can, try to practice on your actual calculator you plan on using it during an exam. It's way more helpful to practice that. All right, let's try to do this. So I'm going to follow my own hint. We're going to focus on distance first. So I'm going to put distance here. And we know the distance that he had to run was exactly 100.0 meters. And we need to convert this to miles, right? Because that's the unit for distance we want in our final answer. So I'll put meters on the bottom. And we know we can't go directly from meters to miles, at least not with our given unit conversions. However, we do have a unit conversion up here that converts meters to kilometers, so let's try that. So I'll say 1 kilometer on the top is equal to 1,000 meters on the bottom, and we're able to cancel out meters. All right, so we're almost there. Then we need to cancel, whoops, that should be a multiplication sign. Then we need to cancel out kilometers, so I'll put that on the bottom. And we need to go to miles, right, which you can abbreviate MI. All right, so now which number goes where? Yeah, 1 mile goes on the top, 1.61 goes on the bottom. We can cancel out kilometers, and we can get to our miles, right? Okay, so let's go ahead and plug that into our calculator. So we've got 100 times all ones. So that's divided by 1,000 times 1.61. All right, my answer that I'm getting is 0.062111.801 miles. I'm going to leave it as is for right now because that's not our final answer. With our final answer, then we'll plug in the proper number of sig figs. All right, now we'll do time down here. And we know he did his world record run in 9.58 seconds. And we know over here that we can convert away from seconds. And the best option that we have is 60 seconds per 1 minute. So I'll put seconds on the bottom, minute on the top. We know there's 60 seconds for every 1 minute. That's good because now we've canceled out seconds and they're gone. All right, now we need to get rid of minutes and get to hours because we want miles per hour, not miles per minute. And we know that there needs to be minutes on the bottom to cancel that out. We need hour on the top. And we know that there's 60 minutes for every 1 hour. And this is good because now we're canceling out minutes and we're left with the unit of hour. Oops. All right, so let's plug that in. So we got 9.58 divided by 60 times 60. And I'm getting an answer of 0.002661111 hours, right? All right, so now we need to merge these two together. Say, all right, 0.062111.801 miles divided by 0.002661111 hours. So let's try that. And I'm getting an answer of about 23.34055.152 miles per hour. Is that what you guys got? Okay, we're not quite done yet. What do we need to do? Sig figs, right? How many sig figs should our final answer have? 3. Okay, because we're doing multiplication and division, we need to stick with the fewest number of sig figs. So instead of writing out all those numbers, I'd say 23.3 miles per hour. Fun bit of trivia though, is he going that speed the entire way? No, that's his average speed. Towards the end of the 100 meters, he's actually going about 27 miles an hour. He could get a ticket in a school zone. It's a little crazy to think about. All right, so that's where we're going to stop right now. There's a unit conversion activity up here. It starts out easier and gets harder and harder as you go to the back page. So I would recommend working with a partner and checking answers as you go along. I'll post the answer key on the course website and on OneNote later tonight, though, so you can check your work.